Hey guys, I am coming at you because I want to just do a quick review or a quick overview of some of the things that we've been talking about. All right, particularly in terms of the remainder theorem and in terms of synthetic division and how we can use both to determine if something is the factor. All right, so let's talk about some of the questions that we have seen and let's do some examples. Let's apply both aspects and let's see how they compare. All right, here we go. So our first question that we have here, and I am going to make sure my whiteboard is connected. Okay, so our first question that we have here, we're going to be looking at the following polynomial. We are going to determine whether or not p plus 6 is a factor. We're going to do synthetic division first. Notice p plus 6 is our divisor. The divisor is written in factored form. All right, so if we're going to figure out what the zero is, we would know the zero is negative 6, and we know that because we need to set p plus 6, or the factor, equal to 0. We are going to solve for p by subtracting 6 on both sides, right? Left side, the 6 is canceled. We have p equals negative 6. So that's how I know the 0 is p equals negative 6. That's where that comes from. So in the backward shape L, I'm going to write my 0. That's my negative 6. Now I am going to look at my dividend, which is the extremely long polynomial, or the polynomial with the higher power. And that is going to be what I'm going to grab the coefficients of. Now, remember, I'm going to do the check just to make sure I have every single term. So I got a p to the fourth, p to the third, p to the second. I got a p to the first. Okay, I'm good. I'm not missing any. So now let me grab the coefficients. For the first term, the coefficient is 1. The second term is 5. The third, it's negative 11. The fourth, it's negative 25. And the last one, it's 29. All right, remember, you're going to drop your first coefficient down onto this line here. And remember, once it hits the line, that is our rule that we're going to be multiplying whatever's on the line by our 0. So I'm taking 1 times negative 6. 1 times negative 6, well, that is a negative 6. I'm going to write that underneath the next coefficient and add those two together. 5 minus 6, or you can think 5 plus a negative 6, okay? That gives me a negative 1 on my line. Then remember, whatever hits my line gets multiplied by my 0. So I'm going to take a negative 1 times negative 6. That's going to give me a positive 6. Adding those together, a negative 11 plus 6 is going to equal what? Negative 11 plus 6. Negative 11 plus 6. You are right. It's going to equal negative 5. Good. So I'm going to write that on my line. And then remember, what goes on your line gets multiplied by your 0. So you guys see how this trend is happening? So negative 5 times negative 6, that's a positive 30. Combining those two together, that gives me a 5, right? And then I get a 5 times negative 6. 5 times negative 6 is negative 30. And then I'm going to combine 29 minus 30. That's going to give me a negative 1. And I'm done. And how I know I'm done is because I have no more coefficients. I am done. All right. I don't keep on multiplying because there's no more. So if once I realize I'm done, I can look in this last column. If I'm talking about whether or not p plus 6 is a factor, I'm going to look in this last column. Okay. I'm looking in this last column. This is using synthetic division. And I notice what? That last number is equal to negative 1, right? That means that is my remainder column. Remember, I told you last column was our remainder column, okay? And if it was anything but 0, we knew that it was not a factor. So I can conclude that p plus 6 is not a factor of p to the fourth plus 5p cubed minus 11p squared minus 25p plus 29. It is not a factor. It is not a factor. Okay, with that being said, guys, let's go down here and let's use the remainder theorem, which is what Miss Bennett, and sorry for the sloppy writing, let's use the remainder theorem. Remember, this is what Miss Bennett called the f of x test, right? So I am going to say to myself, and we have the wrong function here, so let's delete this function. Okay, now that we got that fixed up, we know that all this is telling us to do is to input we know that all this is telling us to do is to use our function notation, okay? So what we're going to do is we're going to ask ourselves, now thinking about the remainder theorem, we're going to say, hey, if we're trying to figure out if p plus 6 is a factor, right? Let me say that our dividend is going to be our function. So that's going to be f of p. So I set f of p, or the longer polynomial, or the polynomial with the highest degree, I'm going to set that to, I'm going to say that that's our function, okay? And then I'm going to find the 0 of my divisor, what I'm dividing by, just like before, okay? And I know that the 0 of my divisor, or the factor p plus 6, is equal to negative 6, right? So I'm going to go ahead and say, let's find f of whatever our 0 is, which was negative 6. What does that equal to? Again, I'm setting that function equal to whatever my dividend is, and I'm finding f of my 0 for my divisor. Okay, so what ends up happening here when you find the value, or you plug in negative 6 into the function, right? What do you get? F of negative 6 would be a negative 6 raised to the fourth power minus 5 times negative 6 raised to the third power minus 11 times negative 6 squared minus 25 times negative 6. and plus 29. Now, at this moment, I'm going to have you pause the video. Just pause the video, go ahead and punch all of that out. And when you punch all of that out, you should get f of -6 equaling to a -1. Miss Bennett, you're amazing. You did all of that in your head. Yes and no. Okay, yes and no. This is the idea of the remainder theorem. All right, this is the idea of the remainder theorem. Are you kind of seeing the connection? Okay, if not, it's okay. Let's do another problem. Okay, we're going to go to the next problem here. Looking at the next problem, we have fast forwarded. We went ahead and just did all the synthetic division for you. All right, and if you were looking what column, if we're talking about is 3x minus 1 a factor, what column are we looking at? What column are we concerned with? And those of you who are saying, well, Miss Bennett, we're concerned with this last column, you're absolutely right. Remember that last column is going to be our remainder column. Okay, that's what we're concerned with. This is our remainder column. Okay. And if I look using synthetic division, I notice that I'm left with a 0 here in the remainder column. So that means that this 3x minus 1 is a factor. You are the factor, right? It is a factor, okay? I know that because remember, if there's no remainder, that means it's definitely a factor. Now, if I want to use my f of z, or my remainder theorem, or the f of x test, which I call the f of x test, I'm going to, again, set my division equal to 0. And I am going to set my, I'm going to find f of, and I got to scratch this out. I'm going to find f of negative, this time my 0 is not -1/3, sorry, it's f of 1/3. And I want to see what is my output, okay? What is my output? Notice, guys, if I plug 1/3 into the function, so I take 3 times 1/3 to the third power minus 4 times 1/3 to the second power minus 17 times 1/3 plus 6, notice my output is 0. F of 1/3 is equal to 0. Okay, what is the connection here? What is the big idea? Well, the big idea that most of you guys should be seeing, if you could write a rule between the remainder theorem and synthetic division, you notice that, hey, when I plug the 0 of a polynomial into the function, right, it is going to give me the remainder, point blank, period. If I plug a 0 of the polynomial into the function, it gives me the remainder. And 0 being, I'm sorry, let me clear that up, guys, the 0 of a factor, okay? So if I'm looking at a factor, I set that equal to 0, or I solve for x. If I plug it into the function I'm testing for, that output should either give me a remainder or it should give me 0, one or the other. But it's going to give you the same thing in this last column. So that last column and your f of the 0 test, as I call it, right, or the remainder theorem, should give you the same thing. So I can use the remainder theorem to test whether or not these are actual factors for the polynomial. Yay! Wait a second, that means I don't have to do synthetic division anymore? Yay! Well, you do have to do synthetic, but to test, do I have to do synthetic division? No, I don't have to. I can now test just using the remainder theorem. That should be exciting news. So if we do you are not the factor again, this time we can test using the remainder theorem? Yes, yes. So moving on, guys, we're going to start playing a little bit more with the remainder theorem, testing whether or not we got factors or whether we don't have factors. All right, guys, see you next class.